Hi, welcome to Beginning Engineers. Today I will be talking about steel, the metal every engineer should know about. It built the modern world. What is steel? Steel is an alloy, which is a mixture of metals. It's made up of iron and other elements, although mostly carbon, which can be up to 2% of its weight. It is used in a wide range of applications, from construction to surgery. Iron takes on two crystalline forms, with carbon as a reinforcing feature. This is what gives steel its high tensile strength. That's a common measure used in material science, the resistance to being pulled. So iron can be body-centered cubic, which means it will have a carbon atom in the middle to make it steel, or it can be face-centered cubic, which means it will have a carbon atom in the center of each face to make it steel. Look at those two images on the right. The top one is body-centered cubic, and the bottom one is face-centered cubic. Notice the difference? Okay, so what is so great about the element of iron having these carbon atoms in the center or the center of its faces? Well, normally, iron has a high amount of ductility, that is, stretching under the tensile force, which can be reduced by including carbon. So adding that carbon prevents the atoms of the iron from dislocating and shifting around as much. It stops them from being all wibbly-wobbly. This increases the strength of the material, but it also decreases the ductility. Most things in engineering have trade-offs like this. So steel, it's not as ductile. It doesn't stretch as much under tensile strength. But that's what you want. You wanted it to be a stronger material. So it's not as ductile as iron, but it sure is a lot stronger under tensile force. So we know what steel is made of, but where does it come from? Who made it first? Well, believe it or not, steel has been produced for thousands of years, but it didn't become more commonplace until the 17th century, with the advent of something called blister steel and crucible steel, which involved heating iron bars with layers of charcoal in between for days at a time, then welding the bars together or melting them down. The charcoal would transfer oxygen into the iron, which is what makes it steel. Steel became even more viable for mass production in the 19th century with something known as the Bessemer process. This involved blowing air through molten iron, again, taking out the impurities and getting carbon into the iron. That picture on the right shows some equipment used in the Bessemer process. The Bessemer process really marks when the transition from wrought iron to mild steel began, at least in large quantities. In somewhat more recent times comes the Lenz-Donowitz process of basic oxygen steel making, BOS, which was developed in the 1950s, and this became the new standard for producing steel. This limits the impurities in the iron by blowing pure oxygen through it, or perhaps some sort of oxygen mixture, whereas the Bessemer process just involved blowing air through it. That's the big difference there. I mentioned some reasons earlier about why steel is important, but you might still be asking, why does it matter? Well, consider these facts. Roughly 1.3 billion tons of steel are produced annually, employing hundreds of thousands of people directly around the world. If you look at people whose jobs depend on having steel, you're talking hundreds of thousands of more employed people. Also consider this. Steel has allowed humanity to build higher skyscrapers. Previously, skyscrapers were less than 138 feet tall. Think about the tallest building today, the Burj Khalifa. It's 2,717 feet tall, much taller than skyscrapers of old. Steel is also used in artificial body parts, such as hip joints, although many other metals and materials are used as well. Most modern cars have over 1,000 pounds of steel. Typically, it accounts for over 60% the weight of most cars. As an engineer, you'll also notice that steel is used in many manufacturing fixtures. Let's talk about some common types of steel. You have carbon steels. Carbon steel is iron and carbon. This accounts for up to 90% of most modern steels. That is just when it's basically iron and carbon, like I talked about before. You also have low alloy steels. That's when you have carbon steel, but with other alloy elements added in. For example, copper helps with corrosion resistance. Manganese combines with other elements to reduce brittleness. Molybdenum makes tougher steel. This is valuable for things like tools and turbojet engines. Then you have alloy steels. So what's the difference between low alloy steels and regular alloy steels? Well, in regular alloy steel, the alloy elements make up more than just a few percent the composition of the steel. In low alloy steels, there are a few percentage points or less of other elements. This is not the case with alloy steels. For example, in stainless steel, which many people are familiar with, there is at least 11% chromium added in. More than just types of steel, steel has official grading designations. They're graded by standards organizations of some sort. So SAE, which is the Society of Automotive Engineers, the American Society for Testing and Materials, the Japanese Institute of Standards, are all good examples of organizations that would grade steel. SAE grading typically composes of a 4-digit number, with the first digit being the main alloying element, the second digit is the second alloying element, and the last 2 digits represent the percent of carbon in the steel, in hundredths of a percent. So for example, 1050, 1050, it would be a plain carbon steel with 0.50% carbon. Here are some examples of what the first digit can mean. 1 for carbon, 2 for nickel, 3 for nickel chromium, 4 for molybdenum. Stainless steel has its own system under SAE. Some things stainless steel can be called would be Type 210, Type 220, Type 310, Type 330, things typically in the 200s or 300s. JIS has its own grades, although I'm not as familiar with these. Some names include S15, S15CK, SUM25, and SUS 303. Thank you so much for watching this video on steel. I hope you understand why steel is so important, what it is, how it's made, and some basic grading. If you like this video, please subscribe. I try to put out about a video a month, and I have tons of videos on other topics. Thanks for watching. Have a great day.